All right,
Four.
let's turn off microphones, please. I'm going to present my screen and give you guys 7 or 8 minutes to work on this warm up. Can you guys see my screen? Yep. All right. So you got 5 questions. I'll put on some music and give you guys 7 minutes until 10:40. So number 1, prime factorization, which is when you make that factor tree. Line all your factors in a row and put a multiplication sign in between, and your prime factorization is that list of multiplication that you're going to do. So number 1 is prime factorization. Number 2, find the GCF of those 2 numbers. Number 3, use the distributive property like we did last week. Number 4, find the GCF and then the LCM, multiply the numbers together. And then number 5, make a factor tree. So I'm going to let the music go. You guys work on that.
Is the song Soul Sister?
Maybe.
Yes, it is, Soul Sister.
Dang. You know your song.
You have your mic on though. Can you turn it off so that there's no feedback, please? Thank you. All right, I'm gonna do about 2-ish more minutes. So keep working. Alrighty. Let's go ahead and go over these. Sorry if you didn't finish up. So I'm going to stop presenting so that it is not backwards on the thing. Not recording, just presenting. There we go. All right. How much of my board can you guys see? Can you see the 1 and 2? Are we good? Alrighty. Okay. Number 1 says, what is the prime factorization of 84, which is the factor tree? So we start with 84, and we need to do our factor tree. So what numbers multiply to 84?
2 and 42.
2 and 42, good. Are either of them prime?
The 2 is?
The 2, so we can circle the 2. Now we need to do what numbers multiply to 42?
2 and 21.
6 and 7.
Good, so we have 2 and 21. I also heard 6 and 7. Does that matter? Can I do either way?
No. I mean, yeah.
Yeah, you can. It doesn't matter which numbers you choose. You'll end up with the same circled numbers at the end, no matter what. Now,
3
what
and
numbers
7.
multiply into 21?
3 and 7.
7 and 3.
7 and 3. Are either of these prime? Can I
Both
circle
of them
them?
are prime.
Both of them are prime. So now, when it asks for the prime factorization, you've done your factor tree. To make it a prime factorization, all you do is write the multiplication problem here.
Okay.
So 2 times 2 times 3 times 7. Because if we were to multiply all of those together, what would it equal?
84.
It would equal 84. So if all it's asking is for you to pull out all the prime factors and make it a multiplication problem. So this would
I
be your
didn't even have to do any math
yeah.
to figure that out.
So this one would be your answer. Does that make sense? The prime factorization of it?
Yeah.
Cool. Number 2, find the GCF, greatest common factor, of 81 and 54. So we need to do a factor tree for 81 and 54. Can you guys see that far over? We're good? Okay, 81. What numbers multiply to 81?
9 and 9.
Good. 9 times 9. Are these prime?
No.
No. What numbers multiply
3
into
and
9?
3 and 3 and 3.
Good. 3 times 3 and 3 times 3. And we know that 3 is prime, so we're good with that one. What about 54? Can you guys see this far? Are we good? Okay, 54. What numbers multiply to 54?
9 and 6.
9 times 6. We just did 9 over here. We know it's 3 and 3. What about 6? What numbers multiply
2
to
and
6?
3.
2
3
and
and
3.
2.
And we know those are prime as well. Now we're not done. We need to find the GCF. So remember, LCM goes on top. GCF goes on bottom. Let's take the numbers from 81 and just write them on top. And now we need to do our matches. Can I match a 3 for this one?
Yeah.
Yep.
Yeah.
What about another 3?
Yeah.
What about a 2?
No.
No, where does the 2 go then?
On top.
In the top row. And then what about the last 3?
You can put that on the bottom.
We can put it on the bottom. Now we're trying to find the GCF, so what do I do with these 3's?
Multiply them.
Multiply 3 times 3 times 3. What is the answer to that?
27.
27. That is correct. 3 times 3 times 3 is 27. That's your GCF? How'd you guys do? Good? Bad.
Good.
Pretty good. And let's look at number 3. We're doing the distributive property of 8 times 9 minus 3. Now remember, we take the number on the outside, multiply it to both numbers on the inside. So what's 8 times 9?
72.
72. The subtraction pulls straight down. You're still going to subtract. And then what's 8 times 3?
24.
24. What is 72 minus 24?
48.
48. Good. There's your answer. How'd you do on that one? Good?
Good.
All right, number 4. This one is to find the product. So we have to find the GCF of 36 and 45. And then we have to find the LCM of 13 and 6, and then multiply those two numbers together. So instead of doing the whole process, what did you guys get as the GCF of 36 and 45? Did anybody get that far? What did you guys get? No one got that far?
He's smacking that keyboard.
No one got that one? The GCF of 36 and 45? Alrighty. We don't necessarily have time to go over it, but you guys know how to find the GCF. Same process we just did. So the GCF of that one is 9. Then if we're finding the LCM of 13 and 6, did anybody get that? LCM of 13 and 6? What did I get? Okay. Anybody get that far?
I almost.
Almost did. LCM of that one is 78. So now we have these two numbers, 9 and 78, and I need to find the product of them. What does it mean to find the product?
Multiply?
To multiply. So we're going to take 78 times 9. Take a second to do that, because you guys can all multiply. Take a second, find that answer.
SpongeBob SquarePants.
I got it. You got the answer.
What'd you guys get?
630.
That's a little bit low.
72. 702.
How do you say that? Not 702.
702.
130.
Good. 702 is your answer. Okay? That one, it's multiple, there's multiple steps to that. Find the GCF first, then find the LCM, and then you have to multiply. So that was a 3-step problem.
Would it be the
Okay.
same if we multiply 25 times 6?
Say that again?
Never mind. Would it be the same if we multiplied 36 times 45 times 13 times 6?
No, that number would be much, much, much bigger than 702.
Bruh.
Okay?
That's
And our last one, number 5. We just need to make a factor tree, so find our prime factors for 48. So, what numbers multiply to 48?
Twelve and 4 or 6 and 8?
Good, 12 and 4. Let's do 12 and 4. Are either of those prime numbers?
None of them are.
No, we can figure out what goes into both. What goes into 12?
6 and 2.
6
Go
times 2.
Brian.
6 and 2.
Okay, we know that 2 is prime, but what about 6?
3 and 2. 3 and 6. 3 and 2.
3 and 2 go into it. What about 4?
2 and 2. 2 and 2.
2 times 2.
And they're both prime.
And they're both prime, so we can circle it. Now, this one
Yeah.
just asks for the factor tree. So we're done with that one. If it asks for the prime factorization, what would I have to do?
Multiply them.
Yeah,
Yes,
the prime
multiply them.
factorization would be writing it out as a multiplication problem. like that. So this is the prime factorization. This is our factor tree. That's the difference. This one looks like an upside down tree. Actually, it looks like a tree, right? Like a Christmas tree. And then this is the prime factorization. It's like a multiplication sentence. Okay? So that is the warm-up. It's all kind of review of what we've done so far. How do you guys feel about that stuff? Good?
Good.
That's doing all right with
Good.
it?
Quizzes,
Yeah.
Miss Jo?
Huh?
Do we have those quizzes?
We don't have a quiz today, no. Online.
Oh, okay.
Yeah, we'll do quizzes on Thursday, I think. We're doing it this
Okay.
week. I just don't remember which day. So this week we're gonna talk about dividing fractions. And I know in 5th grade you guys do adding, subtracting fractions. You guys do multiplying them. And I'm pretty positive you guys talk about dividing fractions. Is that correct?
Yeah.
Okay.
No.
Yeah.
Well, real quick,
Kind of.
let's see. If I were to put, I just want to see what you guys do. If I were to put a problem on the board,
We get the captions.
let's say I put 2/3 times 1/4 on the board. So this is a multiplying fractions problem. What do I do to solve that?
Find the nearest number that they multiply to and multiply the top one that many times to get to like that as many times you multiply the bottom one.
Okay, so you're kind of on the right track. That's for adding and subtracting fractions, not when you multiply and divide. So you're talking about finding a common denominator, right? Finding a number to make it, to have the same denominator. Like 12, this one would be 12. That's for adding and subtracting fractions. When you're multiplying and dividing, you do not need to have a denominator. The bottom of your fraction does not need to be the same. Any other ideas of how to solve this problem?
Multiply the bottom ones together and multiply the top ones together, and then that's your answer.
Yes. So when you multiply fractions, all you do is multiply straight across. So what's 2 times 1?
2.
2. Your fraction bar stays the
3.
same. What's 3 times 4?
12.
12.
12.
21.
Okay. So when you multiply fractions, you just multiply straight across and then you get 2 12ths. Now, do you guys remember how to simplify fractions? How to reduce it to the lowest terms?
Yeah.
What do you do?
You divide it by 2.
So you have to find a number that goes into both the top
Yep.
and the bottom, or a GCF if you want to find a GCF. We know that 2 goes into both 2 and 12. So you would divide by 2 on the top and the bottom. What is 2 divided by 2?
1 and
1.
the answer.
And then 12 divided by 2 is
1 and 6.
6. So we would get 1/6. So multiplying fractions is very, very similar to dividing fractions. There's just one small step you have to do before you use this process. So what we're going to do is first talk about simplifying again, because when you have anything to do with fractions, we have to talk about simplifying your answer to make it in lowest terms. So we're going to talk about simplifying fractions first. We're going to do a little bit of talk about dividing fractions, and then we're going to talk about dividing mixed numbers. Do you guys remember what a mixed number is?
Yeah.
Kind of.
Any ideas? before we get into
24
it?
on top of 8. Or, yeah.
Okay, you're on the right track. So if you say like 24 over 8, 24 eighths,
Mhm.
is that what you mean?
Yeah.
So
It's
this
the top number is bigger than the bottom.
So that one is called an improper fraction, which
A
you will
mixed-
see this. So this is an improper fraction. What's the difference between that and if we say, so let's say 2 and 1/4.
That's a mixed
Oh,
number.
really?
This one is a mixed number.
I got a question on when we divide the decimal, not the decimals, the fractions. If we have a number that is bigger than the other one, how are we supposed to do that?
What do you mean?
Like how when you divide and you have a bigger number outside and a smaller number on the inside? Like how do you make it to where you can divide on the smaller
Like
number?
if you have like 1/3 divided by 3, something like this.
I know, like 1/4 divided by 1/4 or something like that. Like 1/4 divided by 1/3. Like how do you do that?
Oh, okay. Like this, 1/4 divided by 1/3.
Yeah, like how do you do
We'll
that?
talk about a problem like this, but if you do it the exact same way that you would, we'll talk about dividing it, your answer just ends up bigger because you can fit more in there. We'll talk about it.
It gets confusing.
It does. Fractions are probably one of the hardest things that we do. So here we go. But yeah, we're going to talk about improper fractions. We're going to need those as well as mixed numbers. So we're going to talk about how to just divide fractions that are not mixed numbers. And we're going to talk about how to divide numbers that look like this, that are mixed numbers as well. I'm pretty sure you guys did at least touched on it in 5th grade at some point, I think. I'd have to go look or ask your teachers. But the common theme is I ask you guys if you did it, and you guys all tell me no. And then I go ask your 5th grade teachers, and they're like, yeah, of course we did that. So, fun. All right.
How we don't remember things.
I know. So I'm going to present my screen.
All right.
And we are going to, hang on, let me pull it up on my screen before I present my screen. We're going to start with simplifying fractions and a little bit of notes on that. All of what we're going to go over is on the notes. The note sheets that we're going to talk about are on Schoology. So if you need them, again, they're all under today's folder. So you'd go to math, then you go to week 6, and then you would go to Tuesday 9/8 because it's September 9th. I'm backwards, aren't I? There we go. No. Can you guys see my screen? All right. So
Yeah.
let's talk about simplifying. Can you guys see this all right?
Yeah.
Yep.
Alrighty.
Kind of.
So simplifying fractions. Simplified fractions are fractions that are in their simplest form. So usually something like 1/2 is in its simplest form, 1/3, 1/4. It's basically when your fraction cannot be divided by any more numbers. So no number goes into both the top and the bottom anymore. And remind me, if I have a fraction, what's the top called? What's the name of the top number?
The numerator.
The numerator, good. What's the name of the bottom one?
Denominator. Wait, I
Denominator.
thought it was the other way around.
Nope, numerator is on top, denominator is on the bottom.
Okay.
Yep, I don't have a trick to remember that one. Sometimes I have math tricks to help you guys remember things, but that one, numerator's the top, denominator's the bottom. Okay? So once your fraction is in simplest form, there will be no more numbers that divide evenly into the top and the bottom. At that point, there's no more common factors, so you can't divide it anymore to make it any simpler than it is. So here's an example. To simplify a fraction, first you need to find the GCF, which is kind of why we do GCF first. It's kind of a lot of steps. There's ways to do it without finding the GCF. As long as you find a number, any factor that multiplies into both the numbers, you'll be okay. You just might have to simplify it multiple times versus one time. So we'll talk about that too. So first step would be to find the GCF of the two numbers. So 4 and 8, their GCF, the greatest common factor, is 4. That's step 1. Step 2 is to divide the numerator and the denominator. That's something that I see people forget, that you have to divide both the top and the bottom by the number. And when you divide, you get 1/2 in this case. And then once you get down to 1/2, that's as simple as it can go. There's no other numbers that are going to multiply or divide, sorry, evenly into 1 and 2. So 1/2 is the simplest form of the fraction 4/8. And we're going to do a few practice problems. I personally do not find the GCF when I do simplifying fractions. I just find any number that they both have in common. I think that finding the GCF takes a bit of a longer amount of time than you need to do. Sometimes it works. Well, it'll work no matter what, but sometimes it's the fastest way. Other times it just kind of takes longer to find the GCF and then divide. So finding any factor that they have in common usually works quicker. So any number that you can divide into both numbers. So let's start with number 1 and 2 right here. We have 6/10 and then 1/12. So I'm gonna write those on the board real quick. Number 1, 6/10. Number 2, 1/12. Okay. All right. You guys see the board pretty well without me in the way?
Yeah.
So if
1/12.
we were to simplify
Yes.
6/10, we need to find, they ask us to find the greatest common factor, right? The biggest number that can be divided into both 6 and 10. That might take a long time. When you look at this, immediately what number can I divide both of these by? Evenly.
2.
2. 2 goes into both of these, right? So we can just divide by 2, divide by 2. What is 6 divided by 2?
12.
No, divided by
3.
3. 6 divided by 2 is 3.
3.
10 divided by 2 is? What's 10 divided by 2?
5.
5. And now we look at 3/5. Is there any number that can go into both 3 and 5 evenly?
No.
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 I mean, if you think about it, 1 can, right? But if we were to divide this by 1, you would still end up with 3/5, right?
Yeah, and you keep going on forever and ever and ever and ever.
Yeah. So the lowest or the simplest form we have for 6/10 is 3/5. Okay? So you just find a number that divides into both the top and the bottom, do your division. Let's talk about 1/12. Is there any number that can go into both 1 and 12?
Yoshi, what are you doing?
No,
Any ideas?
because the one at the top, you can't do that.
Good. If you have a 1 at the top, it's already in lowest forms. You can't divide the 1 by anything that's going to make it smaller than 1. So if you have 1/12, you're done. If you have 1/4, it's in simplest terms. If you have 1/512, it's in simplest terms because you have a 1 on top. Does that make some sense?
What if you had a 0, though? Like, what if you could divide it by 0? Then it'd be 0/0.
Yeah, so that's a very complex math concept that you'll learn in like calculus that we don't talk about in terms of fractions. But
What's calculus?
calculus is a very difficult math. Okay, guys, Skylar, Yoshi, let's stay out of the comments, please. Okay. And Yoshi will get back in when his screen starts to work. It's okay. Let me look at the problems and let's do 2 more examples really quick. I want to do one that might give us some different.
Do we have an assignment on this?
No, not today.
Okay.
So,
There we
like,
go.
if the numbers like go into like the same thing, like, do we divide it by that?
Yeah. So for this one, 6/24, we're going to find a number that will divide evenly into both 6 and 24. So what number goes into both 6
Is
and
it the
24?
highest? or lowest?
You can choose any number as long as it goes into both. The bigger it is, the sooner you're going to get to your simplest form, though.
You 3 and
So 3?
So we can do 3.
8.
Okay.
6.
What's 6 divided by 3?
2.
2. Over what's 24 divided by 3?
8.
8. So now we have 2 8s. We're not in our simplest form yet because what number goes into both 2 and 8?
Divide them by 2.
2.
Good. Divide
And
by
then
2.
it'll be 1/4.
Good. So our answer here is 1/4. So now when we think about this, 3 goes into 6 and 24, correct? 2 would go into 6 and 24. Another way to do this, the way that they talk about with their greatest common factor, the GCF, anybody know what the GCF of 6 and 24 is going to be? The greatest common factor? What's the biggest number that would divide into 6 and 24?
3.
8.
8 doesn't divide into 6.
3.
It's not 3. 3 isn't the biggest. It is one that it has in common, but it's not the greatest, not the biggest one.
6.
6. 6 goes into both 6 and 24. So what's 6 divided by 6?
1.
1. What's 24 divided by 6?
4.
4. Is that are these the same answers?
Yeah.
Yeah. It doesn't matter how many times you have to divide to get to your lowest terms, as long as you end up there eventually. Okay? You can take as many steps as you need to get to this smallest, simplest form. You'll get there eventually. Does that make sense? That it doesn't have to always be the greatest common factor?
Yeah.
Yeah, so as long as you figure out a number that goes into both, you'll be okay.
I accidentally clicked exit.
That's all right. It looks like the weather's kind of acting up too, so if you're ending up getting kicked off, just get back in. It's all right. I think it's supposed to get rainy.
I got
windy.
kicked off in the first week.
Yeah, I think it's supposed to get rainy and windy, so if you get kicked off, just log back in. You don't even need to tell me it happened. I can see it on
yes, we could see it. Sorry.
Okay. So that was dividing or simplifying fractions. Let's go talk about dividing fractions. I'm going to share my screen and do a little bit of dividing fractions. Alrighty, can you guys see my screen? Good?
Yeah.
All right. So
No.
dividing fractions.
Yeah.
Okay.
Cool.
So to divide fractions, you're going to follow the process of keep, change, flip. Have you guys heard that before?
No.
What?
No.
I don't know if I believe that. I'm going to go talk to your 5th grade teachers. Keep,
I was going to
change,
say the same
flip.
thing.
Why
Okay.
can't it
Don't.
I don't have good
KFC.
memory, so I don't remember.
It's
I
all right.
can't-
We're going to go over it. So
I
let's
can't-
say, let's say that I have the problem.
Change, flip. I know that one.
2/3. We'll just take 2/3 divided by 1/2. Okay, can you guys all? Oh wait, you can't see that. It's probably backwards, huh?
No, it
Yeah.
isn't.
Well, it's because I'm still presenting, huh? Give me a sec.
Why can't it just be KFC?
Because then it's not in the right order. Okay, now we've
KFC.
got. Now you guys can see this, right? 2/3 divided by
Yeah.
1/2.
Yeah.
Okay, when we talk about KCF, I almost said KFC. Keep, change, flip. That means keep the first fraction the same. Keep. Change the division. Does anybody know what I changed the division to?
Comment. No.
What's the opposite of division?
Multiplication.
Multiplication. So you will change your division symbol to a multiplication symbol, and then you will flip the 1/2. You'll flip it so it's 2/1. So your new problem would be 2/3 because that would stay the same. You would change your division to multiplication, and you would flip your 1/2 to 2/1. And then you multiply your fraction.
So if it just said so if it just said divide 2/3, then we would just divide it by the thing that they like, the highest thing they go into. And then
Yes.
if it says 2/3 divided
by
1/2, you divide them into each other, but turn the division to multiplication and like switch them around. So there's two different kinds of divisions.
Not two different kinds of divisions. This is just the process you have to go through when you divide fractions. Keep the first one, change division to multiplication, and then flip your second fraction upside down. There's not like there's a way to describe it, but it's very confusing. And
There's different ways to divide.
But you're not dividing any differently. All you're doing is changing your division problem. The way that fractions work, you change your division problem to a multiplication problem. It's just how dividing fractions work. There is a way to describe it to you guys, but the process is super confusing as to why you do this process. So it's kind of not worth explaining at this point why we do it, because it's very confusing unless you're like super awesome at math. And it's like high school level type stuff that I don't want to confuse you guys just yet. Does that make sense?
Yeah.
Yeah.
Okay, so when you get fractions, and you're dividing, you're going to do keep, change, flip. So KCF. Once you're at this point, you just multiply like normal. So what's 2 times 2? 2 times 2?
6. Oh wait, 4.
No, 4. 2 times 2 is 4.
4.
What's 3 times 1?
3.
3.
Well, right now I have an improper fraction. Do you guys know how to remember how to change an improper fraction to a mixed number?
Don't you have to like put a 1 next to it or something?
Kind of. So let's talk about this, right? You end up with a number that's bigger on top than it is on the bottom. We can't really do that. So what you do is you take the top number, 4, and divide it by the bottom number, 3. So 4 divided by 3. Now, how many times does 3 go into 4?
1.
Once.
Wait, no.
And then you subtract. Okay?
No, 1.
Now, in order to make this into your mixed number, the 1 on top becomes your big whole number. Okay? To make your fraction, the remainder that's left over goes on top. And then what you were dividing by goes on the bottom. So your answer is 1 1/3. Okay, and we'll do that multiple times because it's a process. But you divide, and your whole number goes at the whole number. Your remainder goes on top, and what you were dividing by goes on bottom. Okay.
Okay.
All right, you want to do one more example of this? We're going to spend all week on it, so if you're still confused, it's okay. Let's do one more example before we talk about mixed numbers, and then we're going to have to go. All right, let's do let's do the 1/4 divided by 1/3 that Dallin was talking about earlier. So 1/4 is technically smaller than 1/3, but that's all right.
Yeah.
When we talk about fractions, dividing fractions, you don't have to worry about one being smaller than the other one. It will work out on its own. So if we do KCF on this, we keep the first one, change the middle, flip the second one. If we keep 1/4, it's going to stay the same. I need to change my division to what? Multiplication. If I flip 1/3, what does it become?
3 and 1. 3 over 1.
And now we just need to multiply straight across. What's 1 times 3?
3.
3. What's 4 times 1?
4.
4. Can I simplify this fraction anymore?
No, because the top one is an odd number.
Yeah. Well, not that it's odd, it's that it's prime. So your answer here is 3/4. And it's just saying that 3/4 times 1/3 is going to give you 1/4. Like if you, it's kind of hard to describe. There's a whole model of it, but it's not super conducive to learning this method. But basically, if you do 3/4 times 1/3, you're going to get 1/4. So it's just like flipping it around. But no matter what order these are in terms of if it's bigger or smaller, you can still do the division and it will work out just fine. You just are going to get an answer like that.
Will you get a different fraction if you divide them?
Sorry, my phone was ringing, but I don't know who it is. Okay, let's, was someone asking a question when I walked away?
Miss Jones,
Yeah.
don't you get a different fraction when you divide it?
What do you mean, do I get a different fraction?
When you divide 1/4 divided by 1/2, you get a different answer.
Well, we divided it by 1/3, not 4.
Yeah, never mind.
Wait,
Okay.
do you mean like, will you get the same answer if you keep 1/3 but you flip 1 and 4?
Yeah.
Oh, no, you will not. I mean,
I am completely confused on what you just did because you guys like cut out for me and it just went to this, so I'm confused.
we did keep change flip on this. And to answer your question, no, if you flip the first fraction, you are not going to get the same answer. So always keep your first fraction the same, change your division to multiplication, and then flip your second fraction over. It's called a reciprocal, so you just flip it over. So that's how we got 1/4. We kept it the same. Division changed to multiplication, and then 1/3 flipped to 3/1, and then we multiply straight across to get 3/4. If you flip the first fraction, you're going to get a different answer. So always flip the second one, not the first one. Okay?
Okay.
So it'll always be the right answer if you flip the second one?
Yeah, unless you multiply wrong or something. But yeah, always flip the second one and you should be on the correct process. Okay? We don't have a ton of time left. I don't know if I want to get into the mixed numbers today because it seems like we could use a little bit work on this first. You want to do like 2 more problems and then head out? Do a little bit more practice?
Yeah.
Okay, let's do that.
Yeah.
instead. We'll talk about mixed numbers tomorrow.
Is there an assignment?
No, there's no assignment today
Tomorrow.
or tomorrow. Yeah. We're just practicing together, all together, getting used to fractions again, and then you'll have an assignment on Thursday. Okay? All right, let's do 3/4 divided by 1/2. Okay, 3/4 divided by 1/2. We have our keep change flip, K, C, F. What do I do with this first fraction?
Keep it the same.
Keep it the same, stays the same, 3/4. What do I do with my multiplication? Or sorry, what do I do with the division?
Multiply.
Change it to multiplication. What do I do with my 1/2, my second fraction?
Flip it around.
Flip
2
it,
and
so the
1.
2 is on top and the 1 is on the bottom. And now that we're here, we can multiply straight across. What is 3 times 2?
6.
6. What is 4 times 1?
6. 4.
4 times 1 is 4.
4.
Now, is there a number that goes into both 6 and 4?
2.
2 goes into both, right? Okay, what's 6 divided by 2?
3.
3. What's 4 divided by 2?
2.
2. Okay. Now this is as simple as this one can go. No number is going to go into both 3 and 2, but there's still something wrong with it. We're not quite done. What do we still need to do?
We need to make it to where it's not an improper fraction.
Good. This is an improper fraction. 3 is bigger than 2. We need to change it to a mixed number. In order to do that, we have to divide. So we're going to take the 3. Huh?
1.5.
Yeah, it is 1.5. So we'll take the 3 and divide it by 2 if we use this process. When we get to bigger numbers, this is going to be a much easier process than any other process. So how many times does 2 go into 3?
1 time.
1. So 1 times 2 is 2, and we subtract and get 1. Now this 1 on top becomes the whole number.
And then
Right? Then the 1 on bottom, the remainder is your numerator.
it'll be 1 and 1/2.
And then the 2 is your denominator.
So you put that on the top.
So you get 1 and 1/2. I feel like that was a little bit better than all the arrows I put last time, right? Okay, so the 1 on top, the number of times that your number goes in completely is your whole number. The numerator becomes, or the remainder that's left over becomes your numerator. And then the number you're dividing by is your denominator. Okay? Do one more problem?
Yeah.
Okay. So, let's see. Let's do something a little bit bigger. Let's do 7/9 divided by 2/3. Those are kind of different numbers, right? Okay.
Yeah.
We're going to do keep, change, flip. Keep, change, flip. What do I do with my first fraction?
Keep it the same.
Keep it the same, 7/9. What do I do with my division sign?
Make it a multiplication sign.
Change it to multiplication. What do I do with my second fraction?
Flip it.
Flip
Flip it to 3/2.
3.
Okay. Now we just multiply straight across. What is 7 times 3?
21.
21. Over. What is 9
18.
times 2?
18.
18. So now in the last problem, we simplified our fraction first, and then we changed it from improper to a mixed number. You can either simplify first and then do that division for the improper to a mixed number, or you can just do the division first. It's up to you. Doesn't really matter which way you go. You should get the same answer. So let's just simplify a little bit first. What number can go into both 21 and 18?
3.
3. What's 21 divided by 3?
7.
7. What's
7.
18 divided by 3?
6.
6.
4. Oh.
Now we can do, this is as far as this one's going to simplify. No number is going to go into both 7 and 6, except for 1, and then you just keep going and going and going. Wouldn't matter. So this is the simplified version of 21/18. So let's do our division. 7 divided by 6. How many times does 6 go into 7?
1.
1.
1 time. We subtract 6, we get 1. What is this one up here?
The whole number.
The whole number. Okay. Good. Which one is my numerator, the 6 or the 1? Which one goes on top?
The
The
1.
1.
The 1 is my numerator. Good. That makes the 6.
Then the 6 is your denominator.
Good. So our answer here is 1 1/6 when we divide. Okay?
Yeah. That's our answer. Yeah.
So there's some stuff about dividing fractions. We're going to talk about mixed numbers tomorrow. It's kind of a lot to throw at you in one day, so we're not going to go there just yet.